I hope you have already seen my video on sorting using cards. Like sorting, searching is also very important. So people often find it difficult to understand. We have got a very easy way using cards again for you to understand searching easily. I have cards numbered from 10 to 95 with some missing with me. I will be using these to demonstrate how linear search and binary search work. Alright, let's start looking for the card having number 77 using linear search. In linear search, we will go from the beginning, look through each one at a time. Okay, not 77, not 77, no, not yet, oh no, not yet, not yet, not yet, there we are. So we have found out. Now we were lucky that it was 77 and it came early. You can imagine if you are looking for 22, it would have been the very last card and we would have had to go through all the cards before finding it. So obviously linear search is rather inefficient. It is even more inefficient when we have to find a card that does not exist. Now I am going to look for card bearing number 25. No. No 25. But as you can see, we have to look through the complete set of cards before we could figure out that 25 is not there. To summarize, in linear search, it takes a lot of time to find out when what we are searching for is not there, and even when what we are searching for is there, it depends on where it occurs. It increases with the number of items we are looking for. Now let us see another method which does not have these disadvantages. Now we are going to do binary search. One of the key things for binary search to work is the data must be sorted. I have a deck of cards which is sorted. As you can see, we have it in sequence. There are approximately 70 cards here, starting from 10, 95, which means obviously some numbers are missing. Now let us look for number 64. How are we going to do it? Binary search means divide my data into half. So I see 54. What do I know? Everything in this pile is below 54. Everything in this pile is more than 54. I am looking for 64. So I know what I am looking for is in this pile. So this is no longer of interest. Now let's repeat. Divide this into half. 74. Again, what is here is below 74. What is here is above 74. So not of interest. Divide this into half. 62. Obviously 64 is here, so this is not of interest. Divide this into 2. 70, what is here is more than 70, so this is not of interest. There you go, 64. We found out in 4 divisions. That is how powerful binary search is. Now let's continue our binary search. This time we are searching for something which we know is not there. I know number 25 is not there. I am going to look for 25 in this pack. Same way, we know it is sorted, divide it into 2, 54. So This is not of interest because 54 and below is here. So if 25 is there, it has to be only here or not here. So this is not of interest. Put it aside. Divide it into 2 again. 30. So whatever is here is more than 30. So 25, if it is there, has to be here. This is not useful. Put it aside. Divide it into 2. 15. So 15 and below is here. Not interesting. 25 is in this hand. Divide it into 2 again. 26 and below is here. So this is not interesting. Divide it into 2 again. 18 and below is here. Not interesting. 25 is not here. So now we can assert 25 is not in the data set. Again, we could do it fairly fast in about 5 or 6 comparisons, as opposed to linear search where we have to go till the very end. In other words, we have to look through all the cards before we decided what we were looking for is not there. Here, in about looking at 5 cards or 6 cards, we could have decided that what we are looking for is not there. This is the most important characteristic of binary search. Both in the successful and unsuccessful cases, it takes the same amount of time or the same number of data to be inspected before we come up with the answer. That's it. I hope you enjoyed using these cards to understand linear search and binary search. We only gave you an overview. We did not discuss the more theoretical aspects of it. That was intentional. Please do read up the algorithms to understand the more formal differences and estimates of their efficiency. I hope this video helped you to understand the basics and made you want to look up such stuff. Happy learning and thank you. Sorting algorithms are a very important subject matter of study. I am going to discuss some of the well-known sorting algorithms, but we are not going to be writing code, but instead we are going to be using one of the oldest known pastimes. Hi, that's a pretty tough looking ternary operator expression. Expressions like these generally make beginning students of C and even beginning programmers in C a little wary of the language. Actually, ternary operators allow us to write very concise expressions. You just need to learn to read them.